Hey everyone, I'm Amy Cameron from STL Partners, and today we're talking about one of the biggest shifts happening in telecom operations right now, which is the move from traditional monitoring and event correlation towards true autonomous network operations. So, as networks are becoming more complex with 5G, cloud native infrastructure, and increasingly demanding customers, operators are looking for ways to detect and diagnose and resolve issues in machine time rather than in human time. A lot of vendors are now claiming AI native platforms, but the real differentiator is how AI is applied safely in critical infrastructure environments where the wrong action can have some major consequences. Vitria has been gaining lots of attention in the industry for its approach in this domain, and in particular for its use of knowledge graphs, telemetry, and multi-agent AI to enable explainable and trusted automation. Today, I'm here with Finbar Travers. Hi, Finbar.
Hey,
VP of
Amy.
Customer Solutions at Vitria, and we're going to look into what's actually required to move from AI assisted operations to true autonomous resolution and what that means for the future of self-healing networks. Our first question today is in the industry, for example, at Mobile World Congress, which just happened a few weeks ago, everyone has been talking about agentic AI. It's all over the place, lots of demos. So from your experience in Vitria, what's a secret sauce that you guys have that differentiates you compared to others?
Of course, Amy, that's a very good question. So I think you maybe indicated some of that in your intro, but at Vitria, really, our focus is on helping our customers move from what we call a system of reporting to a system of understanding. So what exactly does that mean? So traditional operations tools and even more advanced observability and AI ops systems have kind of focused on capturing signals from data like metrics, logs, alerts, traces, and so on, and then correlating those signals into incidents. They then base their automation decisions on these incidents, which essentially are only a snapshot in time or a snapshot at a particular point in time of the causes and effects of a particular problem. So, in effect, this makes these tools quite reactive and probabilistic, especially when they're relying on generative AI for answers, which many of the modern tools, of course, are. So, they don't have a fundamental understanding of things like the service topology, the dependencies within the system. They don't understand the relationships between the network and the service, for example. They also don't really have any context about historical incidents or actions that were taken to resolve those incidents. So all of this, we would argue, at least, are required to make accurate predictions and to avoid hallucinations. Again, hallucinations being a very hot topic in the industry at the moment when it comes to LLM. So as these tools really don't have the full picture, they essentially need to guess or infer based on a statistical likelihood. So without that fundamental understanding, or what we call knowledge, it becomes extremely difficult to move from observability to automation, and even more difficult to move from automation to controlled autonomy. So, maybe to answer your original question, at Vitria, we're enabling context-aware understanding of topologies, of things like topologies, blast radius risks, revenue, and regulatory implications through continuously evolving knowledge. And that knowledge is captured in knowledge graphs. It's described by a semantic layer or by semantic dictionaries. And it really helps to ensure the trust in the automation when dealing with mission critical infrastructure, which of course we are in many situations. So essentially, that knowledge becomes the control layer for the autonomous operations.
Yeah, great. And I think that that is definitely something the industry is getting to know better, the sort of the importance of sort of understanding the topology and having that knowledge. Can we dive a little bit deeper into the control layer in terms of what information do you typically capture in those knowledge graphs and how is it used in order to sort of deliver that trust in the AI?
Absolutely, absolutely. So, first of all, I should say that we call this layer the via knowledge plane, and it's intentionally designed to be self-evolving. So, that really means that it automatically discovers knowledge from the incoming data streams. It automatically maps that data into an ontology, and then it continuously updates itself over time as more information is ingested by the system. So I think that's very important, that self-evolving nature of the knowledge plane. So also, unlike traditional data lakes and relational databases, it provides structured context, and that means both data and the semantics, as I mentioned, that are required for AI to move from being intelligent, which of course the AIs are today, to having a true understanding. Okay. Secondly, and maybe to answer your original question, is that it includes information like real-time mapping of physical and logical topologies. And that data is both learned and inferred from the data being ingested. It also includes institutional wisdom. So that's, for example, diagnostic data extracted from historical incidents, from ITSM data, and that includes data like remediation workflows, root causes, and previous fixes and their outcomes, which of course can then be applied to future predictions. And then, very importantly, through the semantic layer, through the semantic dictionaries that I mentioned, it provides operational guardrails that help enforce technology, business, and regulatory constraints or regulatory rules on the AI behavior. So, for example, if I take a 5G SA network, the knowledge plane connects the infrastructure and the cloud resources to the network functions, to the applications and the microservices that make up those network functions, again, to the historical incidents and resolutions, and ultimately to the services being used by the customers. So in a sense, in essence, it's providing a real-time model of the end-to-end service, and it understands how the service and the business actually run. And then the AIOps tool or AIOps platform can then factor all of that understanding into its decision-making process.
Hmm. Cool.
Okay.
Yeah, so I mean, I
Sounds
can see
good.
I can see how this is how this can be valuable for the industry. Obviously, you mentioned 5G standalone. That's something a lot of operators are grappling with. Do you think you could give us a real world example of a specific issue, like a nice complex issue that Vitria is helping to solve?
Absolutely, and I'm always interested in the real use cases myself. So let me give you a concrete example from the telecoms world. This is actually an example we implemented with one of our customers quite recently. So in this situation, within the radio access network, multiple radio units at the multiple different cell towers began reporting a slow user throughput. That, of course, indicating that customers on those cells are having a poor data experience, or so I guess something we've all experienced before, slow data connection. So in this example, the symptoms, the visible symptoms appear at the radio units or actually with the end customers. But the root cause was actually several layers deeper in the network, or in fact, in the related application layer. So for this particular example, the actual root cause of the issue originated within the aggregation layer of the transport network, which is 3 or 4 levels upstream from the radio access network. And what we saw is that links on one particular aggregation router appeared to be congested, but and they had basically high link utilization, they had high packet loss. But when you actually go deeper, the root cause was actually that the virtual router container, so that virtual router application itself responsible for forwarding packets in the network, did not have enough resources to cope with peak demand. So typically what you would see in traditional systems is that they would often fail to detect these types of non-causal local relationships because all of the intermediate components in the service delivery chain are reporting normal status, they're reporting normal health. Or what will happen is that they will treat all of these individual issues as isolated problems, and they don't understand the full implication of the end-to-end issue. And that's really because in the industry, the access network, the transport network, and the application layer are typically monitored by completely different tools or by completely different teams. And what's required is essentially manual diagnosis where these teams get together and they manually correlate these types of problems. So with the via knowledge plane, with knowledge graphs, with graph-based reasoning, we're able to reason across all of these relationships and then identify the true root cause of the problem. So once we know the root cause of the problem, which again was in the application layer of the virtual ruler, we're then able to use agentic AI based on the intent that we've discovered, I guess, that we've figured out to implement the best course of action. So in this particular situation, there were multiple actions taken, including adding more resources to the offending Kubernetes component, which of course you can do automatically through an agent. And also, then we raised a ticket to the network planning team to assess additional future capacity requirements for a longer term resolution of the problem. So this, I guess, overall, this type of approach results in significant reductions in mean time to repair, of course, very importantly. And we've seen reductions of 60 to 80% with our customers. It also results in improvements in operational efficiency. For example, we've seen 50 to 80% reduction in manual effort, where human input is really only required for the most complex scenarios, obviously freeing up quite a lot of resources as well. But more importantly, is that it results in happier customers because the issues are resolved before they know they have a problem.
Mm. Yeah,
Okay.
I think we all want to be those happier customers. We've always been
Exactly.
on the
Exactly.
experience end of that. And I can see the sort of the multi-domain orchestration and visibility is definitely something that some of the more advanced operators are really trying to achieve with
Yeah,
their,
of course. Yeah.
current activities. So obviously there's a lot of work to be done to achieve this, but what's your sort of longer term vision for Vitria? How do you see this, sort of technology evolution happening over the medium or long term?
Yeah, yeah. It's a so I think our longer term goal, I guess at the highest level, is really to automate incident resolution, as I touched on, through knowledge-driven agents for a wide range of telco and enterprise use cases. And ultimately, what we're trying to do is support our customers achieve their goal of level five autonomy over the next couple of years. So we've already implemented many of these capabilities, and we will be showcasing some of them at FutureNet World in London in April. I may see you there, Amy, I hope. But of course, there's always more innovation to be done in this particular space. So these agents, they need to be intent-based, very importantly. They need to be able to reason, and there's many different types of reasoning. They need to be able to explain their decisions, is very, very important. And kind of related to that, they need to be able to provide traceable steps in their analysis. So we also want our customers to be able to be self-sufficient, very importantly, to be able to build their own agents and to support their ever-increasing portfolio of use cases or use cases specific to their particular environment. So I guess at Vitria, our focus will remain squarely on innovation. Partly, of course, that's related to staying ahead of the market. But more importantly, we want to continue to deliver value to our customers and ensure that the services that they provide to their customers, us in many instances, meet the higher than ever expectations for service quality and reliability. And of course, we're doing all of that in dynamic environments where complexity is dramatically increasing all of the time.
Finbar, thanks very much for sharing your thoughts today.
Thank you very much, Amy. It was my pleasure talking to you.